Calories. Just an innocent number printed on food packaging. Some obsess over it, treating a few extra or a few fewer calories as a life or death situation, while others generally don't pay much attention to it, or they deliberately ignore it. In any case, calories play a crucial role in nutrition, making them the most popular metric when it comes to dieting. So, depending on your dietary goals, nutritionists will tell you to eat a certain number of calories a day. But what the hell is a calorie, you might be asking? Calorie is a unit of energy. So when you consume food, it's much like fueling up a car with gasoline. The food you eat gets converted to energy that is used to keep you alive and moving. Most foods we encounter possess a certain amount of energy that our bodies can use as fuel. This energy can be expressed in a few different units, one of which is the calorie. A single calorie is defined as the amount of energy required to raise the temperature of 1 gram of water from 14.5 degrees Celsius to 15.5 degrees Celsius. This might seem arbitrary at first, but it will make sense soon. So, calorimetry was invented in the 18th century as a way to measure the energy released by reactions. Let's say you wanted to measure how much energy is released when potassium reacts with water. If you threw a chunk of potassium into a nearby river and then tried to measure the heat with a thermometer, you'd be disappointed to find out it doesn't work like that. The heat from the reaction would quickly dissipate into the air rather than be captured by your thermometer. That's why you need a closed system instead of an open one. So you grab 2 polystyrene cups, knowing that they are good insulators, and place one inside the other. Then you pour some water into the inner cup and cover it with a lid that has a thermometer attached. Voila, you got yourself a simple DIY calorimeter. Now, when you react something in the water, a change in temperature can be observed on the thermometer. If you know the temperature change, the mass of the water, and the specific heat capacity of water, you can calculate how much heat was released by the reaction. The result is measured in joules, which is another unit for energy. When calorimetry was first invented, energy wasn't measured in joules, it was actually measured in calories. The reason a calorie was defined as the energy required to raise the temperature of 1 gram of water from 14.5 degrees Celsius to 15.5 degrees Celsius was purely for convenience. Water was abundant, and that specific temperature range ensured that certain properties of water, like its specific heat capacity, remained consistent. And that's how calories came to be defined. Today we mostly encounter calories on food labels. But how are calories in a food actually measured? It's pretty simple. You just dry out the food, burn it in a calorimeter, and measure the temperature change. For these measurements, bomb calorimeters are used instead of regular calorimeters. And no, they don't explode the food, although that would be pretty cool. They are called bomb calorimeters because they can withstand vigorous reactions such as small explosions and combustion. Once the food is burnt, scientists get a calorie reading which is then listed on the food label. Although most foods go through this process to determine their calorie content, there is a rule of thumb for certain nutrients if you know the amounts present. Proteins and carbohydrates provide about 4 calories per gram, while fat provides 9 calories per gram. But there's some nuance here, because your body might not fully burn all the food you eat. Many factors influence whether a food is fully or only partially digested. So, calories represent the amount of energy you put into your system, not the amount of energy your system actually uses. This is an important distinction to understand. Calories are mainly used in US, Canada, Latin America, and Asia. while other parts of the world primarily use kilojoules. If you live in Europe, you can see that there are both calories and kilojoules listed on the food labels. If you live in a country that lists only kilojoules, to get the number of calories, you just divide the kilojoules value by 4.184, because 1 calorie is equal to 4.184 kilojoules. But there's a common misconception about calories. A calorie is not the same as a calorie. Confused yet? Good. A calorie with a lowercase c is the original calorie. It equals to 4.184 joules, the energy needed to raise the temperature of 1 gram of water from 14.5 degrees Celsius to 50. A calorie with an uppercase c is actually 1,000 lowercase calories. In other words, an uppercase C calorie is a kilocalorie, abbreviated as kcal. The lowercase calorie can also be called a gram calorie. This causes confusion when reading food labels. But it's simpler once you know that food labels always use calories with an uppercase C, even if they sometimes indicate it with a lowercase c. That's because if they used gram calories, your average chocolate bar would have about 250,000 calories. Gram calories though, not the big ones. Even though the two values represent the same amount, using gram calories would make tracking energy intake a disaster. That's why kilocalories are the preferred option. But instead of calling them kilocalories, we just say calories for convenience. But with an uppercase C, of course. Don't forget that. Some common terms associated with calories include empty calories, calorie surplus, calorie deficit, and caloric density. Empty calories refers to foods that have a lot of calories but very few other nutrients. Basically, these are low-quality foods that mainly provide energy, while other nutrients are negligible. Calorie surplus occurs when you eat more calories than your body needs, resulting in weight gain. Calorie deficit is the opposite, eating fewer calories than your body requires, leading to a weight loss. And finally, caloric density is the number of calories per specified amount of food. For example, 100 grams of chicken contains 190 calories, meaning it has a caloric density of 1.9 calories per gram. So that's all I have to say. See you in the next one.